Good morning. So in this lecture video, I am going to explain programming the external interrupts. So as I explained in the previous video, programming the timer interrupts. So in this lecture video, I am going to explain how the external interrupt occurs. Then how do we program it? How do we write the interrupt service routine for external interrupt? So programming external hardware interrupt. So as you know, these are the hardware interrupts. They are external, in the sense external to the microcontroller. So external hardware interrupts are, we have two external hardware interrupt, that is INT0 on pin P2 P3.2 with the vector address 0003, and one more INT1 on pin P3.3 with the vector address 0013H. And there are two types of activation. One is level triggered interrupt and another one is edge triggered interrupt. So level triggered in the sense, in this mode pins are normally high. Initially the pins are all high. So whenever low signal is detected, if a low signal is applied to them, it triggers the interrupt. That means to say the low level signal must be removed. So whenever the low level signal occurred, interrupt is occurred. So that should be removed before the execution of RETI instruction of the ISR. Otherwise, again and again the interrupt is going to be occurred. So this is level triggered. Otherwise, another interrupt will be generated. So now let's see how do we sample the low level triggered interrupt. That means to say, see, we have a pins P3.2 and P3.3 are used for normal IO, input or output. Otherwise, unless INT0 and INT bits in IE register is enabled. So when the interrupt are enabled, the controller keeps sampling, in the sense keep monitoring the INTX pin. INTX means here it can be either 0 or 1 for low level signal once in each machine cycle. That means every machine cycle it is keep monitoring the low level signal on INTX pin. So the pin must be held low state until the start of execution. That means, so if the low level signal is occurred, that must be in the same low state until the start of interrupt service routine. If the pin is brought back to logic 1, there will be no interrupt. And for this duration, the low level signal is around 4 machine cycle. That means to say that low level signal must be held at least a minimum 4 machine cycle, but it should not be more than that. And this is due to level triggered interrupts are not latched. Level triggered interrupt are not stored in the any register, like timer overflow flag that is stored in timer 1 overflow and timer 0 overflow, but it is not like that. So level triggered interrupts are not saved. So let's see, this is it should be minimum high for 1 machine cycle and low for machine cycle, and then again the interrupt will be occurred. So on reset, IT0 and IT1 are both low, making external interrupts are level triggered. That means to say, as I said, so interrupts can be level triggered or edge triggered. So that is decided by the pin, by the bit IT0 and IT1 of T-con registers. If it is 0, they are level triggered. If it is 1, they are edge triggered. So on reset, they are 0, so making the hardware interrupts level triggered. Now let's see edge triggered. So we should make IT0 or IT1 1 using an instruction set bit IT0 and IT1. So the external hardware interrupt becomes edge triggered. Now how do we sample edge triggered? So here it should be minimum I for minimum 1 machine cycle and low for minimum 1 machine cycle. Otherwise interrupt will not be occurred. So external source must be held high for at least 1 machine cycle and low for at least 1 machine cycle. So while ISR is being executed, that means interrupt service routine is executed, INT pin is ignored. That means to say IE register and IE bit and IE1 are called interrupt in service block. This is IE0 and IE1 are the bit of TCON register. They are also called as interrupts in service flag. If they are 1, it indicates interrupt is executing. So it will be becomes 0 at the end by executing RETI instruction. So if it is 1, when falling edge is detected at the INT pin and stays I during the entire execution of ISR, and it becomes 0 by RETI instruction, that is the last instruction of ISR. Activation. See, let's see, this is INT 0. It becomes level triggered if IT 0 is equal to 0. When it is, that will be equal to not gate, and then it activates the interrupt. That means it goes to the address 0003. If IT 0 is equal to 1, it becomes edge triggered. That means whenever the falling edge occurs, that is saved in IE0, and then it goes to the address 0003. So that is what I said, level trigger interrupt are not latched, but edge triggered interrupt are latched. So for the level triggered interrupt, we should manually remove the low level signal before the execution of IET instruction. But here it is saved in the IE register. It is equal to 1. It indicates interrupt is occurred and it is servicing interrupt. And it becomes 0 automatically when RETI, that is the last instruction of ISR, is executed. Similarly for IT1, same thing, but only the changes is, yes, INT1, IT1, okay, and IE1, and the address is 0013. This is 0003, this is 0013. We'll consider one example program. Two switches are connected to pins P3.2 and P3.3. When two switches are connected to port pins P3.2 and P3.3. When a switch is pressed, the corresponding line goes low. So when the switch is pressed, the corresponding pin becomes 0. That means if 0 is detected, means the switch is pressed. Write a program to light all LEDs connected to port 0 if first switch is pressed. That means, so we have connected LEDs to port 0 as well as port 2. If first switch is pressed, light all the LEDs which are connected to port 0 on. And if the second switch is pressed, make the LEDs which are connected to port 2 on. So this is what the question. Here we use interrupts. We use to detect whether first switch is pressed or second switch is pressed. We use a interrupt. So we enable external interrupt 0 as well as 1. So to enable IT0 and IT1 interrupt, this is what the value to be loaded. First we should make all enable, and then corresponding IEX enable external interrupt 1 and enable external interrupt 0. So the corresponding hexadecimal value is I is equal to 85H. This is what the value to be loaded into IE register to enable external interrupt 0 and external interrupt 1. Let's see the program. So we'll start with ORG00H and we redirect. So that is the LGM main. Okay, and here the main program, only one instruction, that is we load 85H into IE register to enable IT0 and IT1 interrupt. Nothing else. Okay, just wait for control SGM back. Okay, now whenever the interrupt 1 external interrupt 0 occurs, it will come to the address 0003H into 0 vector address. So here we need to toggle, make all the LEDs which are connected to port 0 on by copying 1 1. So move P0 comma as 0 FFH. Turn on the LEDs and then wait for a while. So move R0 comma as 255H and decrement jump not 0 R0 comma LED1 comes here only. Just wait for a small time, short time, and return. So suppose return means it will come to the main program, it is keep on. Suppose if the switch 2 is pressed, it will come to the address 00 13H. So there we make LEDs which are connected to port 2 on and wait for a short time. Wait for a short time and return to the main program. So this is the simple program. That means here in this program we enable the INT0, external hardware interrupt 0 and external hardware interrupt 1 to detect whether the switches are pressed or not. I mean, if the switch 1 is pressed, we make all the LEDs which are connected to port 0 on. If the switch 2 is pressed, we make all the LEDs which are connected to port 2 on. Okay. We are not monitoring using the software instructions. Clear now? So this is how programming the external interrupt. We'll discuss programming serial communication interrupt in the next video. Thank you.